So we already learned about the hash function. Okay. So we learn the hash function contain hash code, and then we have the hash code and compression function. And then there are some ways on hash codes and also some ways on compression function. So actually, yeah, if you are familiar with this domain, you are able to learn about blockchain. You are able to learn about Bitcoin. Okay, so the basic idea of the hash code here, it is about how to change a key. So the key it can be anything, and then we can change to integer value. Or nowadays you can see that the blockchain or the Bitcoin is trending, and they use some kind of code. Okay, so they have the hash code. Yeah. So for example, they have the hash code. Oops. So they use the hash code for changing any keys into integer. Okay. So there are many algorithms in the hash code. This course is only give you the basic idea about the concept of hash code. So last Monday, we already learned about the collision handling. So there is a possibility when you have the same value in the same index, then yeah, collision may happen. Collision means yeah, the same value in the same sorry, the there are some values that is in the same index. So for example, like this one, 54, 28, 41. So those are the value. So like this one. Okay, let me check. I can edit.
Yes.
Okay, so I want to know for 54 mod 13, what is the result? $54 mod 13. So it means it is the remaining value. What is the result? If we know that 13 multiplied by 4 equals to 52. So there are remaining values equal to, what is the value? I can edit it. Hello? Are you there? I can edit it.
Yes, yes, I'm here. I'm here.
Yeah. So what is the value? 54 mod 13.
2.
2. Okay. So yeah, 54 mod 13 equals to 2. It means this is the hash code. It's key. So we want to put the value 54 in the index 2. Okay. Now let me have another value. Kangmin. Are you here, Kangmin? Okay. What is 28 mod 13?
2.
2. Okay. That's correct. So 28 mod 13 equals to 2. And 28 is also in the index 2. So we call it this is collision. Okay? Because the different values, but they have the same index. Now let me okay. Kim Yurim.
Yes.
Okay. Now, what is 41 mod 13?
Two.
Sorry?
2.
2. Okay. So we have again the same value, which is 2. So here 54, 28, and 41, when we deal with the compression function k mod 13, all give you result of 2. Then we call this is collision. We have only one space, but there are 3 values. That's why we say that this is the collision handling. And when we want to put all the values in one index 2, so there are some strategy. So the first strategy is separate chaining. So we call this is the separate chaining because 54 we will put first, and 28, and then 41. So it is chain. Now we learned about this map with separate chaining before. Okay. And also, this is the method, or this is the function that you can use in the separate chaining. So there is another strategy. So the first strategy is what we call as the separate chaining. This strategy, we call it linear probing. Okay. So in the linear probing, we want to handle the collision by placing the colliding item in the next or circularly available table cell. Okay. So let's see if we have this hash code X mod 13, and then I want to have those keys. Okay. So I have those keys, and then I want to put it into this kind of array. So we have a place. So we have 13 place, and the index starts from 0 until 12. Now let's go to the first 18. Now let me check. Kim Jong Young.
Yes.
Okay, so what is 18 mod 13?
5.
18 mod 13, 5. Okay, good. So we know that 18 mod 13 equals to 5. We put 18 in the position index 5. Okay, thank you, Jong Young. And then I will call Kim Jong Un.
Yes.
Okay, I would like to know what is 41 mod 13.
2.
2. Okay, perfect. Then we put 41 in the index 2. Okay. Now, Kim Ji-yeon.
Yes.
Okay. I would like to know 22 mod 13.
9.
Oh, sorry. Okay. 22 mod 13. What is the result?
9. 9.
Sorry.
9.
Yeah. 22 mod 13. Okay, 9. So we want to put 9 in the, we want to put 22 in index 9. So maybe I can say something like this one. We already have 18 here, and then we have 41 here, And then now we have 22 in index 9. Okay. And then we have 44. Okay. 44 mode 13. Kim Hyung-soo.
Yes.
Okay. 44 mode 13. What is the result?
5.
44
5.
mode 13 equals to 5. Okay. If we put in the 5, what happened? We already have a value in the index 5. And we cannot put 44 in the index 5. In the linear probing, we want to put if the colliding item occurs, we put in the next available table cell. So we put 44 in the next of the colliding item. Because the colliding item is 5, so we put into the index 6. Third, we have another 59 mode 13. What is 59 mode 13? Bakyun?
7.
Bakyun, are you here?
Yes, I'm here. 7.
Bakyun? Yes. 59 mode 13 is 7. Okay. Then I can put in the 7 because 7 is empty. I put 59 here. Now I have 32 mode 13. So the next is 32. Park Song-eun?
Yes.
Okay, what is 32 mode 13?
8.
32 mode 13?
8.
8? Are you sure?
Yes.
Yeah?
Oh, no. 6, 6.
Yeah?
Yes.
What is the result? 6 or 8?
6, 6.
6. Okay. 32 mod 13 is 6. Now let's see what is in the 6. Okay, we already have a value. So if we put 32 in the 6, it is collision. We need to put in the next. Okay, what is the next? 59. Oh, this also already filled with a value. Then we cannot enter this one. So we need to fill in the blank. So the index 8 is empty. So we fill with this value 32. Okay. And then we have 31. Okay, 31 mod 13. Park Se-eun.
Yes.
Okay, Park Se-eun. What is 31 mod 13?
5.
Yeah. 31 mod 13. 5. Okay. Then we will check one by one. 5. Okay, it's not empty. Then we cannot put here. How about 6? Also, it is not empty. So we cannot put here. 7 is not empty. We cannot put here. 8 not empty. 9 not empty. So we need to put into the index 10 because it is still empty. So 31 is placed in the index 10. Okay, thank you. And then Bae Jong-soo. The last number is 73. What is 73 mod 13? Choi Jong-soo, are you here?
Yes.
Yeah, okay. So what is 73 mod 13?
8.
8? Is it true? 8?
6, 6, 6.
Yeah? 6? 6 or 8? Okay, so you need to know what is the remaining. Okay. So we have 13 multiplied by 5. It is 65. Okay. So 65.
Yeah.
Then the remaining is
8.
8. Okay. Okay. Be careful when you calculate this mode. Okay. There might be some questions about this one. It may be in your final exam or in your quiz. Okay. Then I know that the result is 8. So I can put the 73 in the index 8. But it is not empty. Then we go to the next. It is not empty. We go to the next. It is not empty. Okay, we can see here is empty. So we put 73 here. So the result is like this one. Okay. So it is the step by step to fill in the hash table using the hash code. Okay. So this is the assumption that the hash code is X mod 13. Okay. With the linear proving, actually, we will find the empty slot. We want to find the empty space. If we want to find the empty space, then whenever we calculate the HK or the hash code, so we probe consecutive location until one of the following occurs. So if an item with the key K is found, or an empty cell is found, or n cells have been unsuccessfully probed. So you can take a look on this one. First, we want to get K. So K is the value like 73, 41, 52. And then with the HK, it means we want to convert the X into an integer value by using the mode. Once we have the I, so we will start the P with 0. So it will be repeated until n. So it will repeat it until the number of the size of this hash table. And then C is the index, C is the value of AI. So A means the hash table. If the C is empty, then you can just return the null. Yeah, so it means no value. But if the C get key equals to K, then you want to get a value. Otherwise, so you will go to the next until we reach the number of the size. So if you cannot find any K in your hash table, then return null. So this is the search function. And then if you take a look on this one, can you guess what is the big O? So Jungmin?
Yes.
Okay. Can you guess what is the big O?
O-N.
on. Okay. Yeah, because we have the p start from 0 until n. Yeah, so we can say that the worst case will be n times. Okay, thank you, So Jungmin. If we want to update, so for example, we have a new value. So the new value will be placed into the hash table. So here we have this statement. To handle insertions and deletion, we introduce a special object. We call it available. And this object, available, will replace the deleted element. So once you remove in one particular slot, it will become available. So if there is a new item, you can just update with the new item. So we remove k. It means we search until we get the k, and then if there is k, comma o is found, then we will replace with available. So we want to remove k and then change with available and then return the value, or this is the o. If we cannot find the k, then we will return null. So that's the step by step to remove. If we want to put, so put means we want to update one cell. So we want to put k, so we want to put in the key k with a value of o. So we will throw an exception if the table is full. Okay, so if all table already filled with the value, then we will just give like an error message. And then we can start, if the table is not full, then we can start at the cell hk. So hk means the function we got from the hash code. And then we probe consecutive cells until one of the following occurs. So if we find the cell, whether it is empty or available, or the n cells have been unsuccessfully probed. So it means like when we go to every cell, so it is still not passed by this repetition. So we will finally store the k comma o in the cell I. So the cell I is if it is empty or if it is available. So this is the code for the linear probing. Yeah, we have the class probe has map, and then we will check whether it is available or not. And then we want to find the slot. So the slot, finding the slot means, we will do this repetition. Okay, so we learned before about the repeat until n. Okay. So this is just while true. So if it is known, then we will return false. So if we can find, we will return true. And then this is only the get item, this is set item, and this is delete item. So that's the common function when you deal with the class. So when you create any class, you need to provide the get, you need to provide the set, and you need to provide delete. Okay, so those three functions should be available in any class that you have. We learn about the linear probing. Okay. About the linear probing, we just put the value in empty slot. So now we learn at least two. Okay. So the first is separate chaining. Okay, and then we learn about the linear probing. So the third is double hashing. Okay. What is double hashing? Double hashing use a secondary hash function. So this is the key point, secondary hash function or DK. So in the first one, we have HK. HK is the hash code. But if the item is collision, okay, so if the item, if there are multiple items in the same K or in the same index, in the linear probing, we will put in the next table or in the empty slot. But in the double hashing, we will use the additional hash function, or we call it decay. So after the HK, if it is not empty, we will apply decay. So the formula will be something like this one. I plus j multiplied by dk, and then we will do the mod n. And then j will be any value from 0 until n minus 1. So this is the rule. The secondary hash function or the decay cannot have 0 values. And the table size must be a prime to allow probing of all the cells. Okay, so do you still remember prime? What is prime? Kim Doksu? Kim Doksu? Oh, maybe, yeah, I got an email that he's in the hospital. Okay. Nur saya?
Yes.
Okay, what is the meaning by prime?
Um,
Prime, what is prime?
I'm not sure.
Yeah? Prime number. Okay. Okay. Prime number is a number that can be divided by 1 or by
Greater
its
than
own
one?
number.
Oh, okay.
Okay, so for example, 2, 3, 5, 7. What about 9? Is 9 a prime number, menurut saya?
It's not. It cannot be divided by 2, so I don't think so. Or
9
a
can be
prime number
divided
is
by
like a
2.
number that is greater than 1, right? So
Yes.
apparently 9 is a prime number.
9. So is it a prime number?
Yeah, it is.
Oh, it is? Why?
Because it's greater than 1.
Greater than 1?
Yeah.
Then 10 is a prime number? So a prime number is a number that can be divided by 1 and a number that only can be divided by its own number. Okay. So if it is 9, can we divide 9 with other numbers? We call it like this one. 9 divided by 2. What is the result? Menurut saya,
It's 4.5.
4.5. So we say that 9 cannot divide it by 2 because the result is not integer. Okay. So what the meaning by it can be divided by its own number because we want to get the integer value. So 9 divided by 3. What is the result?
3.
3. Then 9 can be divided with other number. So 9 is not a prime number. Okay. Oh. Okay. So 9 is not prime number. 2, 3, 5, 7, 13, 17, 19, and so on. So you can check all those numbers. So those numbers, which is a prime number, that can be recommended for the table size. Okay. And for our course, I will just use the common choice of the compression function. So the common choice for the compression function in the secondary hash function is this one. We have the 2k and then the q minus k mod q. So let's assume that q is a prime and then q should be less than n. Okay, so this is the common choice for the compression function in the secondary hash function. And the possible values for d2k, yeah. So we can select like 1, 2 until q. So maybe let's see the example for better understanding about this one. Now we have the same numbers, okay? We have n equals to 13. So this is a hash table storing the integer keys that handles collision with double hashing. Okay. So we have n equals to 13. And then the hk, or the first hash function, is using k mod 13. And then the second hash function, we use this function. So this is already set. Actually, you can define by your own, but maybe for this example, let me set 7. 7 is a prime. And then we want to move minus k mod 7. Okay, so let's take a look on this example. We have this value 18, 41, 22, 44, 59, and so on. Okay. Now, let's see one by one. We first try to do with the first hash code 18 mod 13. So what is the value 18 mod 13 yang Yusuf?
5.
5. Okay, then we will put in 5. So we will put in 5. But as we know, we already also have the tk here. Okay, the tk equals to 7 minus k mod 7. 7 minus 18 mod 7. So what is the result? Wonjong there. Wonjong there, are you here? Wonjong there? No? Oh, you're here? Okay. 2? Is it true? 18 mod 7. Yeah, this one. Maybe, yeah, this is a pattern explanation. So
Is
what is 18 mod 7?
2.
18 mod 7 is 2?
Yes. Wait. No. 3.
3?
Yes.
I mean 18 mod 7.
Is 4.
4. Okay. Then we have 7 minus 4. The result
Yes.
is
3.
3. Okay,
Yes.
that's correct. Thank you. So it means if 5 is not empty, then we can put in the slot 3. So here, 18, so we have 5, and then we have decay equals to 3. Since the prop 5 is empty, then we can just put in the 5. Okay. Now next, we have 41. So 41, we have 41 mod 13. Either one. What is 41 mod 13?
2. 2.
Sorry, there is something wrong with my mic. Hello, hello. Can you hear my voice?
Yes.
Yeah, so something wrong with the microphone in my desktop. So, okay, let me just use this one. Say, oh, okay. I'm not sure what happened to the desktop. Wait a moment. Okay, then let me continue here. Okay, 41 mod 13. Okay, I cannot do anything here. How can I do something with the desktop here? Okay, so something wrong with my desktop. I will fix on the break time. Okay, but let's see. 41 mod 13 equals to 2. Okay, so it means we will put 2 in the we will put 41 in the index 2. Okay, and then if we want to calculate the decay, when we want to calculate the decay, means 41 minus 7 minus 41 mod 7. I cannot write here. Hmm. Okay, something wrong with my computer. I don't know. I cannot move all the mouse and the keyboard. Then, okay, let me stop here first. Okay, so let's have 10-minute breaks, and I will continue after the breaks. Okay, sorry, I don't know what happened with this computer. I will fix the computer first. After 10 minutes, let's continue our class. Okay. So you can have break. So after 10 minutes, we will start again the class.